Okay, so this is about predicting. This is from chapter 3 in the book on case studies, data mining with R, learning with case studies, and this is about predicting stock market returns. And I'm using this version of R, and I just loaded in the data mining with R package, DMWR, and let's see. So I installed it, and then I loaded it with the library command, and then I added in some data from that called GSPC. So it's a little bit different than a matrix of data, but you can treat it for now like a matrix or a data frame, actually. So you could try the head command. So it's got prices on it. So now we're going to be working with our own separate data, but let's start like this. And in the book they also talk about how to work with a MySQL database, but we're not going to do that here. And of course we can just add the data in, our data in, as a regular CSV file. And it is possible also to download it from the web, but we won't do that either. So we can see that there's a date here, there's an open price, a high, a low, close, a volume. These are just fields. And this is called time-independent data. I'm sorry, time-dependent data, because it has time as one of the variables. And sometimes we label these as y. This should be a sub, not an exponent. Y sub 1, y sub 2, y. And this just means this the price as a function of as a time series. So this would be like the price at time 1, price at time 2, and so on. So it's just the sequence of prices. And for many time series problems, you want to predict the future price or the future y value as a function of the past y values. Now we're going to be working with two packages, XTS and zoo, and these are actually classes, and I think XTS extends the zoo class. Okay, so let's try that. So here we're running this command, and basically what we're doing is we're creating a sequence of dates here. So you can see we're starting at this date, and we're increasing by by day. So we have 2000 January 1st, January 2nd, and so on. And there should be 100 of these. And what we have here is, this is like supposedly the price. So normally you would have like a price vector in here, but now we have just random numbers, 100 random numbers, I guess. Actually, these are random numbers chosen from a normal distribution. So anyway, it's just a list of numbers, so that when we run the previous, or when we check this, we see we have just this list of random numbers drawn from the normal distribution, but a list of random numbers here, which are supposed to sort of be like a price. I mean, not a price, but it's just for our example. And using this function to create these dates gives us access to some functions that are built into this class. So that's probably why we're doing it. So this gives the date, gives a kind of a date, and then we're generating a sequence of these of length 100, and we're incrementing the sequence by day. So if you want to access the price on January 5th, you could do something like this. Or you can even do it like that. Or you can do it like this. This is for the 4th, but same thing. And you can do this, which will get you all of the prices, I guess, in April. And this one, I believe, takes you from the 27th to the end. And this one, I guess, takes you from the 26th to the 3rd. So you have these, because it's in this format, you can access these things using these kinds of commands. And there's one more here, which takes us to the 3rd of January. Now we can also do what we call multiple time series, and that's where you have more than just one time series. So you might have the opening price and the closing price and whatever, some other price, some other time during the day. And so each of those is kind of a time series. And so you might want, that would be called a multiple time series. So you might have like a time series like this. So here's the date, and time series 1, time series 2, time series 3, time series 4, time series 5. That would be a multiple time series. So we can use this command, get a matrix. So we do this, we get this matrix, which is 25 random numbers, rounded off to 2 decimal places, and the matrix is going to be 5 by 5, so we're going to 5 by 5, so we're going to get a matrix like this. And then with that matrix, which is here, we can use this XTS to create an object which has these dates associated with it. So we get this. Okay, so this MTS now is this kind of object. Now we could just read this in using a much simpler read CSV file, which is probably what we'll do, but if you do it this way, I guess you get access to all these functions. So anyway, we could do this, and this is going to give us for this date, which actually is the entire month of January, these 2 columns. So we get that. That didn't work. Okay, I forgot a few steps actually. So I redid it from the beginning because I after this step, which we did, I had forgotten to do this step, and then I had done this step, but I hadn't done this before it. So I redid it all these 3. And now I try this out, and I do get what we should get here. The 2 columns, these 2 columns. And also, if I print out MTS, I do get all the columns. I didn't, actually last time I didn't have these column headings. Now, if I want to go and extract from the MTS just the core data, in other words, out all the headings and column headings and row names, or not really row names, but the time here. If I just want to get this data here, so-called the core data, I can do this to get that. So this MTS is an XTS object, and this is going to be adequate to store stock quotes data. and actually because we can get multiple time series, and also with irregular time lags. So it doesn't have to be regular time lags. These are regular time. These are not regular time lags, are they? Right. Because dates, stocks don't always trade every day, so you wouldn't necessarily want regular time lags. Actually, this is a pretty big jump. But anyway, so we don't have to have regular time lags, which is good for stocks because they don't trade on Saturdays and Sundays. And we can store multiple time series in here. So this is a convenient way to do this.